half harmonic oscillator. We call this one as famous half harmonic oscillator. We shall solve this one ideally, okay, in WKB method. Okay, we shall find energy eigenvalue of this one in WKB method. Right now, I mean, we don't want to solve Schrodinger equation for this one. Okay, logical answer. Okay, pick up. I mean, one side infinity. Am I right? Other side harmonic oscillator potential, isn't it? Now you take your full harmonic oscillator. In the full harmonic oscillator, you pick the state, okay, whose wave function goes to 0 at x equal to 0. I mean, here, look at here. Potential is infinity means particle is not entering to this region. Particle is not entering to this region means wave function is 0. Wave function is 0 in this region means continuity of the wave function requires that wave function should be 0 at x equal to 0. Are you getting point? Pick up all of your wave function, okay? Pick up. They should start with 0 only here. They should be 0 when x is less than 0. They should start with 0 here. Okay, speak up all of your wave function. Okay, psi n or something. Okay, speak up. So psi n of 0 should be 0. So because when x is less than 0, okay, this psi n equal to 0 because particle cannot enter that region. You take full harmonic oscillator. In the full harmonic oscillator, you pick the state whose wave function is 0 at x equal to 0. What are those state? Not ground state. Ground state is Gaussian, which is not going 0 at x equal to 0. First exact state. N equal to 1 state. Am I right? Then n equal to, not n equal to 2 state. Am I right? N equal to 3 state. Odd number state, odd quantum number state. Can I say like this? Figure. So that's why when you see the options, look at it here. These two options are nonsense. Why? Wave function is discontinuous. It will never be discontinuous. These two options are possible. Okay. What he is asking, let us see. Which one of the following represent possible ground state? Ground state means for this one, what is the minimum first state? That is n equal to 1 state. Am I right? Pick up. That n equal to 1 state looks like this. I mean, for full harmonic oscillator, it is like this. Am I right? But half harmonic oscillator, it is 0 here. Okay, it is like this here. Any question on this one? Speak up. Anyone on Google Meet? No, that's a good idea. Am I right? This is ground state. Ground state had no node. Am I right? 0 to infinity is your region of interest. No node. You can say like that. Okay. Let me draw ground state. Ground state is like this. Okay. Speak up. Your first exact state. That means n equal to 2. Am I right? What is the ground state energy? Speak up. Can you tell me? 3 by 2. 3 by 2 h bar omega. Okay, you should know what is the energy. In one problem, I asked what is the nth energy for this one in our design MCQs. Maybe like this. Am I right? Isn't it? N equal to 2, 3 by 2 h bar omega, 5 by 2, 7 by 2 h bar omega. This is the ground state, first exact state of this half harmonic oscillator. Okay. Now 0. I mean, this is first exact state. Am I right? It has one node. That logic works. That logic works. Okay. I mean, 0 to infinity is our region of interest here. Now 3 by 2 h bar omega, 7 by 2 h bar omega. I mean, how to write nth state here? Wait a second. In En is equal to n plus half. Okay. Pick up h bar omega. You have to pick n is equal to 1, 3, 5, and so on. Am I right? Now, if you want to rewrite that one, En, that's, I mean, odd n. Am I right? Can I write 2n plus 1? Okay, plus half. Okay. H bar omega. This one should start with 1. That's why n will start with 0, 1, 2, 3. What do you say? Either this one, either you quote that, speak up. Either you quote that n equal to 135, or if you want to run n from 0, you write 2n plus 1. What do you say? Or you can make 2n minus 1 also, but start n with 1. Am I right? I mean, you can 2n minus 1 is also odd number, but don't make it negative. Start n with 1. Okay, speak up. That's the difference. Okay. I mean, this one actually we see full harmonic oscillator and we restrict, we choose, we pick. Okay, but here I mean we want to write what you call direct what you call energy for this one. I mean we want to run n like integer. Okay, all integer. Okay, if anyone have solved this one, you reply to that instruction channel message with your solution. Okay, speak up. So a particle of energy E moves in one dimension under the influence of a potential. If energy is greater than V of x for some region of x, which of the following graph can represent bound state wave? Bound state means whatever we discussed, those are bound state actually. It should be normalizable solution. Okay, this is not normalizable. Wave function is discontinuous here. That's not possible.
So C and D we can do, but D why is D not?
This D wave function is discontinuous, isn't it? Wave function is
But psi
discontinuous.
square still normalizable.
No, it is wave function is a solution of second order differential equation. Okay, if it is discontinuous, how do you take second derivative?
So in one
Okay,
case,
from the solution, if you want to go to Schrodinger equation, you take first
so
derivative.
there was one case where we did not take second derivative.
That was I mean first derivative was discontinuous, not wave function itself.
Oh.
Isn't it? First derivative can be discontinuous. Okay, wave function will never be discontinuous. I'll come to that point in direct delta problem. Wave function will never be discontinuous. It should always be continuous because it represents probability. Its mod square represents probability. Probability cannot suddenly change or something. Okay, that may be the basic idea. Okay, and one more thing, if this function is discontinuous, how do you take first derivative? You can't take first derivative. Second derivative again doesn't, I mean, cannot be taken actually. Okay, I mean, it is not solution of any second order differential equation. Dirac delta problem should be separated. Speak up. In Dirac delta problem, derivative will be discontinuous, but wave function is still continuous in all problem. Okay, among these two, which one you choose? I mean, this looks like this. Am I right? I mean, keep on moving, oscillatory. I mean, this is normalizable, no doubt. Okay. I mean, if it is only one option, you choose this one. One option problem. This is TAFR problem, I think. Isn't it? Now, it looks like these heights are increased here, but it's not so clear what will happen further. Am I right? Speak up. Actually, oscillatory function, okay, I mean, that integral, I don't think it will converge to any value. Area under the curve, it will converge to any value.
It will also be a function.
Huh?
It will also be a function.
I don't know. Okay, what oscillator function we have? Suppose sine square x, you integrate 0 to infinity or minus infinity to plus infinity. No, sine square will become anyway, you take mod square, am I right? So sorry, mod, if you take mod square, its integral is infinite, am I right? Negative will also come positive. Area under the curve will be infinite if it continues, if it is oscillator. Okay, speak up. Suppose it looks like sine square x minus infinity to plus infinity dx, that diverges. Okay, that cannot be normalized. Yeah.
How is it sine square?
I mean, this if okay, if it is minus sine x, when you take mod square, you do mod square and then integrate in the normalization. Okay, speak up. I mean, it will come to positive part. Am I right? When you take mod square, then area under the curve positive only. I was integrating this one, not this one. Integrate mod square of this one. Okay, speak up. A ball bounces off the earth. You asked to solve this quantum mechanically. Solve this problem quantum mechanically, assuming that Earth is infinitely hard sphere, considering surface of the Earth as the origin, implying potential is equal to infinity and linear elsewhere. Okay, wait a second. Let me write this one. He gave V of x like this. Okay, Pick up. It's equal to infinity when x is less than 0. It's equal to mgx. Okay. When x is greater than 0. It is like this. If this is surface of the earth, our ball cannot penetrate into earth. Okay. This is your positive x-axis. This is your origin. If ball is anywhere here at a distance x from the origin, okay, speak up. Its potential energy is mg into x. X when x greater than 0. When x less than 0, our ball cannot penetrate into that region. Potential is infinity. Can I say like this? Which one of the following wave function is physically admissible? Okay, you draw this potential first. Okay, speak up. So v of x, okay, as a function of x, it is linear here, it is infinite here. That means particle cannot enter here. Okay, speak up. And it should be normalizable in the, our region of interest is 0 to infinity. It should be normalizable here. Continuity of the wave function demands that again wave function is 0 in this region. Particle cannot enter. X less than 0 means inside earth. X greater than 0 means above earth. Is that okay? Speak up. Then particle cannot enter here. Wave function should be 0. That's why wave function should be 0 at x equal to 0. Okay. Wave function should be 0 at x equal to 0. Wave functions are not 0 at x equal to 0. Is that okay? So these two are possible. Now it should be normalizable in the region 0 to infinity. Isn't it? So that one, look at here, this one, x e power kx. I think he gave k greater than 0. X e power kx, as x tends to infinity, it is blowing up. It's not normalizable. But this is normalizable, 0 to infinity, that exists, that integral exists. Okay? Speak up. At x equal to 0, this is 0. Perfect. But which of the following wave function is physically admissible? Non-normalizable wave function are not physically realizable. Okay, that's why it should be normalizable in the region 0 to infinity. Okay, speak up. And wave function should be continuous. Whenever potential is infinity, your wave function is 0. Okay, that's why at x equal to 0, wave function should be 0. Okay, speak up. That's how I have chosen. Whatever the experience we have, apply and solve the problem. You take it neatly. Okay, I will use capital psi. Okay, c naught. Can I write c naught psi naught? I prefer psi naught in place of phi naught. Okay, plus c1 psi 1. Okay, phi naught and phi 1 are what you call orthogonal eigenstate of ground state and first excited state of one-dimensional harmonic oscillator. Okay, how do you find expectation x? Okay, speak up. You do psi star x cap psi dx. You put that operator, ladder operator. What is this one? So that's equal to root of h bar by 2m omega. Okay, speak up. C naught star psi naught star plus C1. When I see all options, they are real. Am I right? C naught psi naught plus C1 psi 1. I'll make it simple. So A plus cap plus A minus cap operated on C naught psi naught plus C1 psi 1. This is Weichel problem asked in many exam. Okay, speak up. Anyway, we are solving and I designed my question also. Okay. Now among many, only I think A plus operator on psi naught, it will become psi 1, root 1 into psi 1. That is needed because you have that psi 1 state. But A plus operator on psi 1, that will become psi 2. Psi 2 is orthogonal to both of these. Pick up. Its inner product will be 0. Okay. A minus operator on psi naught, 0. Okay. Lowest state. A minus operator on psi 1, that will become psi 0, root 1 into psi 0. Okay. Speak up. So that's why root of h bar by 2m omega. Okay. I'll write this one. C naught psi naught plus C1 psi 1. You should have a good hold on this one. Doing it quickly. Okay. Ladder operator. Okay. That will become, I think, C1. Sorry. C naught psi 1 A minus operator on this one C1 psi naught dx. Am I right? Speak up. That's equal to root of h bar by 2m omega. Okay. Psi naught term you take it outside. C naught C1 integral of mod psi naught square dx. Okay. Plus C naught C1 integral of mod psi 1 square dx. Okay. Speak up. 2 C naught C1 because these are normalized. Okay. Speak up. Root of h bar by 2m omega. 2 C naught C1 if they are real. Otherwise, I think C naught star C1, C naught C1 star. That addition will remain, isn't it? Otherwise, that term will be C naught star C1 plus C naught C1 star. This term will remain, I think, if they are complex. Okay, speak up. Now, for which values of C naught and C1 this is highest? Option A, C naught equal to C1 is equal to 1 by root. For this one, okay, C naught C1, C naught C1 value is 1 by 2. Okay, for this one, okay, speak up. C naught C1 value is root 3 by 4. Which one is higher? 1 by 2 is higher or root 3 by 4 is higher? Option A is right, okay? 1 by 2 is higher, am I right? Option A is right. 0.43, this is 0.5.